Okay, hello all. This is a video on some people asked for some help with some questions from the reviewing for the test. So we've got over here exercise 3L questions 6, 7 and 9 we'll have a look at, and then chapter review tech-free questions 8 and 14, and a couple of people have asked for question 8, so that'll be interesting to look at that one. So I got the textbook open, so we'll start with 3L question 6. So a construction firm has won a contract to build cable car pylons at various positions on the side of a mountain. Because of the difficulties associated with construction in alpine areas, the construction firm will be paid an extra amount, C dollars, for each pylon, given by the formula C equals 240h plus 100h squared, where h is the height in kilometres above sea level. A. Sketch graph of C as a function of h, comment on the possible values of h. Okay, so our equation is C equals 240h plus 100h squared. Okay, so we need the graph. So we need intercepts first, and then we can get the turning point from there. This is a pretty easy equation. We can take out h as a common factor. 100h. Okay, we'll let C equal to 0 to find our intercepts. So it follows on 0 equals h bracket 240 plus 100h follows on h equals 0 or 0 equals 240 plus 100h using the null factor law. So we get negative 100h equals 240. H equals 240 on negative 100 equals negative 2.4. Okay, so I'm going to sketch over here. Okay, so we have our graph, and we have one intercept at negative 2.4, and we have another intercept at 0. Okay, so our graph, it's a regular parabola, so it's going to go like that. And it says comment on possible values of h. Okay, so at the moment, that's any value of h is quite, if we're thinking abstract or numerically, any value of h is currently possible, but we need to think realistically in terms of this real world problem. Okay, construction firms built cable car pylons, so like ski lift pylons, at various positions on the sides of a mountain. Okay, they're going to be building the mountain in an alpine region. Where is that going to occur? Well, that's when we have a high altitude. Okay, so in Australia, our alpine region starts from about 1 kilometre and up. Okay? And if you know anything about Australian alpine regions, the maximum height of them is about, I think the highest mountain in Australia is about 2.4 k's high. So for Australia, okay, our H range for this, okay, we can go up to about 2.4 kilometers, okay, and we'll just say for now above 0. Yeah, we're not going to be building pylons below sea level for a ski resort. It's just not going to happen. Okay, you could also say, and this is where this problem is open to interpretation, you could probably say that's also a 1. Okay, so that means if I change my color, okay, all of this isn't counted. Okay, and we'll go with from 0. Okay? And my graph is going to come up something like this. Okay? And these videos are more just to give you an idea of how to do the problem. I'm not going to do all the parts of it. What I would do is then go, okay, let h equal 1 kilometer, let h equal 2, 2.4, maybe substitute some of those values in and find the equivalent, okay, C values. That's going to be our C, H. Okay, that's how you go about that problem. B, does C have a maximum value? Well, this goes on, if we just look at it numerically, no, because it's a parabola going on and on upwards forever. That means H could approach infinity, C can approach infinity. But realistically, because H has a maximum value of 2.4 in Australia, 2.4k is the highest mountain, then C would have a maximum value at 2.4. And then part C, what is the value? C for a pylon built at an altitude 2,500 meters. Okay. The trick with this is we need H, let H equal to 2.5 kilometers, yeah? Okay, because our equation is height in kilometers. So that's how we do question 6. Question 7. Okay, a tug of war team produces tension in a rope described by the rule 209 T equals 290, all in brackets 8 small t minus 0.5 t squared minus 1.4 units, where little t is the number of seconds after commencing the pull. Sketch the graph of t against t, stating the practical domain. Well, don't we love having a capital T and a little t in a problem just to help confuse us even more? So t is equal to 290 8t minus 0.5 t minus 1.4. Okay, so we need the graph. Okay, so we need our intercepts. Okay, so how do we go about this? Well, we're going to be using the null factor law, so we're going to let capital T equals 0, so the 290 is going to disappear. So we're left with this quadratic. That's looking like, that's not nice. That's not nice having. Okay. Let's just start doing some working and see where it goes. That's what we actually need to get used to in maths, is trial. So we're going to let tension equals 0 to find our x-intercepts. So it follows on 0 is equal to 2. And I'm going to rewrite this equation in more order that we're used to seeing. So we get 0 equals negative 0 squared plus 8t minus 1.4. Okay, I want to get rid of this half in front. So let's just multiply everything by 2. So 0 is equal to negative t squared plus 16t minus 2.8. Okay, where to from here? I would say the 2.8 is a pain, but 16 is nice. So we could maybe try and complete the square. So 0 is equal to negative t squared plus 16t. So half 16 is 8, then square it. 64 minus 8. Negative there though. Negative. Let's get rid of the negative. Okay, by multiplying everything by negative 1, so we'll get t squared minus 16t. No, plus 2.8. Okay, equal squared minus 16t plus 4 minus 64 minus 8 equals the 8 squared minus plus, that's going to be I can get my brain to work. Negative 61.2. Okay, so we get, well, this isn't nice. Doing this cas free, this is not nice. We would get t minus the square root 62 bracket t minus a plus the 62. I've copied this problem, right? Yes, I have. That does give us our intercepts. We might actually go instead. Okay, let's just substitute some values because let's think about what are some allowable. So for this problem, it's a tug of war problem. What's some allowable values for time, little t? Well, we can't have a negative time. We start the competition at 0, we assume, and then we go on from there. So we could just substitute in some values of t, and we'll get some values for that. So let's try that. So let's let little t equals 0. So big T equal to 290, 0 minus 4 equals 290 by 290 by 4 is equal to 0.1 of 290 is 29 times that by 4. 4 nines are 36. 4 twos are 8 plus 3, 1116. So this is going to be 290 plus 116, 6, 1, 406, negative 406. Okay, so we have a negative 406 here. The graph is going to be something like that, I'm assuming, but let's try t equals 1, t is equal to 290 bracket 8 minus 5, 4 is equal to 90. 8.9, going to get 0.1. This question is screaming doing it on CAS. Let's go have a look at worked solutions. Sometimes that's L question 7. Yeah, solving with CAS. Okay. Solving with CAS. Yeah. So stick it in your CAS, solve it. Solve it that way. Does C have a here? What's the greatest tension produced during a heave? Yes, there'll be some value up the top. This graph actually comes up like that. Now it is saying stating the practical domain. Now this is an interesting one. Okay, tension. Tension is a force. Can we technically have a negative tension in the rope? Well, depends if you said the negative was the direction of the tension, but tension's pulled in both directions, so no. So yeah, you need to find when the intercepts are when they come up through here, and then that's the practical domain, because if you imagine having a negative tension in a rope, then that really means instead of being pulled, it's being pushed, and the rope just sort of coils, collapses. It's not a solid bar. You can't have a compression on a rope. So the practical domain would be between the two intercepts. So that's how you do that one. Okay, question 9. An arch on the top of the door is parabolic in shape. The point A is 3.1 meters above the door. The equation y equals ax squared plus bx plus c can be used to describe the arch. Find the values of A, B, and C. Okay, so we're looking at this diagram here. We need to find the values of A, B, and C in the equation for this quadratic path. Okay, so what we have going on is something like that. Okay, and it's y equals ax squared plus bx c. You can see that diagram. No, you probably couldn't have seen that diagram the whole time. Let me bring... Okay, we're looking at this diagram here. Okay. So we know we have some coordinate points. So we've got 0, 0. We have over here looking at diagram, that's going to be 1.5 across 0. And we're told this value here, capital A, okay, has a height of 3.1. And we know the turning point's halfway between the two intercepts, so that would be 0.75. 0.75. Okay, so we have 3 coordinate points we need to solve for this equation. Okay, so we're going to substitute them in. I'm going to call that 0.1, I'm going to call A 0.2, I'm going to call that 0.3. Okay, so sub in 1 follows on that 0 is equal to A squared plus B, 0 plus C. We get 0 equals C. That's nice. We get that straight away. Our intercept. Okay, so we now know that y is equal to ax squared plus bx. I'm going to sub in 2. Okay. So it follows on that we get 3.1 is equal to a 4 all squared plus 3 on 4b, and we also get sub in 3 follows on, we get 0 equals a 1.5 squared plus 5b. Okay, so we have 2 simultaneous equations. Let's actually work with this one here quickly first. So we get 3.1. Let's try and write it as simply as we can. Let's square the fraction. So that's going to be 9 on 16. A plus 3 on 4b. And one here we get 0 equals 1.5. We can write that as 3 on 2 instead. Square that. So we get 9 on 4a plus 3 on 2b. Okay. Now we could do some simultaneous equation work with this. and solve. You could also solve it using simultaneous equations in your calculator. Let's just see if they actually do it. They just use that form. Yeah, which was the other way. I was going to say that you could do it, because if you notice, if I scroll all the way back up to the start of my notes, right up here, the other way you could write it, okay, is that question's a little tricky in that they give it to you in y equals ax squared plus bx plus c, but we have two intercepts for that question, so you're much better off using the form y equals a x minus e x minus f, sub in your two intercepts there, and then just solve to find a, which mean just doing one substitution. So you could do it that way, but you could definitely nut this one out by hand. It would just be a little bit of work trying to get your A and B cancel out, but add your CAS, stick in your CAS. Realistically, a bunch of these 3L problems there, CAS indicative. So that's how to do those. Right, let's get to this question 8 from the Tech Free. Where is it? Find the values, oh yes, one of these ones. Find the values of P that will make the quadratic a perfect square. Woo! Okay. Let's go in new color. Make it a perfect square. 5P minus 1 x all squared minus 4x plus 2P minus 1. How to make a perfect square. So a perfect square we want to factorize into some ax, in this case it'll be a minus b all squared. Okay, I had a complete brain fade, and it shows why I shouldn't record these videos too early as well as too late. Yeah, perfect square. Perfect square is going to have the form like this, okay? Y equals something like that, perfect square. Or it could be, it's plus or minus, but it has to be the consistent sign. So if we use the null factor or we expand that, we get this ax. We'll assume a negative b, ax minus b. Okay, when we expand a perfect square, and if we use the null factor law, follows on 0 is equal to ax minus b, or 0 is equal to ax minus b. You'll get x is equal to, in this case, b on a, x is equal to b on a. We get the same solution. When we have a perfect square, x is the same solution. Okay, we have what's called a repeated root. Okay, so we have one solution. What's important about a quadratic that has one solution? The discriminant is equal to 0. I couldn't get my brain to work there for a while, so what we need to do is find the discriminant of this equation and then make it equal to 0, and then the p-values where that occurs here will turn this into a perfect square. So the discriminant is equal to b squared minus 4ac is equal to, b is going to be negative 4 squared minus 4 by 5, 1 by 2p minus 1. You get 16 all by 10p squared minus 2p 1 equals 16 minus 40p squared plus 7 by 4 is 28p plus 4 equals 40 squared plus 28p 12. That right? Yes, I have. Okay. We can take out a common factor, so we'll take out the -4, we get 10p squared minus 4, get my brain to work, is 7p minus 3. Okay, let's do the cross method. 3 and 1 it needs to be. 5 and 2. 10 and 1. It'll be 10 and 1. 10 and 1 be -1 there. So that's -10p. 3p, add those together gives me -7p, which is the middle term. That works. Roll down a bit here, so it's equal to -4 bracket 10p plus 3 bracket p 10p plus 3 p minus 1. Okay, so that's our discriminant. Factorize, we're going to let our discriminant equal 0. So it follows on that 0 equals -4 p 1, therefore equals 0, p minus 1 equals 0. So p is equal to 1, or p is equal to -3 on 10. So if we make p either of those two numbers back way up here, that'll turn that into a perfect square because it means that its discriminant will be 0. That means we get a repeated root if we factorized it, and a repeated root means it's one solution. Hence why we know the discriminant has 0. So that's how we do that problem. Hope that helps. Sorry for that's a bit of a ramble. At it early on a Sunday morning. That's how you go about those problems. Definitely with those 3L1s, most of those were definitely let's get the CAS involved. Any more questions, stick them up on Edmodo.